All right, so let's go ahead and talk about behavior of gases. Now, gases are fluids and their particles move rapidly in all directions. So many of the properties of gases are actually very unique to itself. For example, gases expand to fill the containers they're in. So no matter what container, what thing they're in, they're just going to fill the whole space. They spread out easily and they also mix with one another easily as well. They have low densities and they're compressible, meaning we can squeeze them down into smaller sizes. And because the reason why we can do all of these is because unlike solids and liquids, gases are mostly empty space. So all gases share all of these properties. So moving on to the idea of gas laws. Now, gas laws, they're laws that help us understand and predict the behavior of gases in specific situations. And there's three different gas laws we're going to talk about today. The first one's Boyle's law. Now, the equation for Boyle's law is P1 times V1 equals P2 times V2. And Boyle's law is actually a representation of an inverse proportion. Inverse means opposite, meaning as pressure goes up, volume goes down, or as pressure goes down, volume goes up. And because this is an inverse proportion equation, the graph is going to be more like a kind of a curve going down. The next gas law is Charles' law, and Charles' law has the equation of V1 over T1 equals V2 over T2. Now, this equation represents a direct proportion. Since we know inverse is opposite, direct means the same, meaning as volume goes up, temperature goes up, or as volume goes down, temperature goes down. And direct proportion equations have a graph that has just a straight diagonal line. And our last gas law is Gay-Lussac's law. Gay-Lussac's law equation is P1 over T1 equals P2 over T2. And this gas law is just like Charles, since they're both fractions equaling each other, it is also a direct proportion, meaning the same. So as pressure goes up, temperature goes up, or as pressure goes down, temperature goes down. And again, the graph is going to be a diagonal line. So with this idea of gas laws, let's go ahead and talk about different variables. All these, what does P, V, and T equal to? Okay, so we just talked about the three different gas laws, and if you notice, they have either P, V, or T as their variables. So let's talk about what those are. So if we have a variable P, P represents pressure, and the unit for pressure is always going to be ATM. Now, if we have a unit that is V, V is volume, and for this class, for this chapter, the unit for volume is always going to be liters. And then finally, T is actually temperature. And the unit for temperature for this chapter is actually going to be K, which is Kelvin. And the reason why we use Kelvin for science is because you never really get a negative number. So it makes calculations more uniform throughout multiple countries when we're sharing data. And now let's go ahead and do some practice problems of gas law calculations. Okay, so our first problem for a gas law calculation says the pressure of a gas rises from 1.03 atm to 2.38 atm. If the initial temperature is 360 K, what is the final temperature? So whenever we do gas law calculations, I'm always going to give you three numbers with 3 units after that. So for every single number unit, we're going to go ahead in circles. So you should have 3 circles. So our first circle is going to be our 1.03 atm, then 2.38 atm, and then our 360 K. Now, also the problem is always going to tell you what to solve for. And when we figure out what to solve for, we're going to underline it. Okay, so we just previously talked about that pressure is ATM, volume is liters, L, and temperature is Kelvin, K. So looking at our 3 circles, we got to figure out what variable. Are they pressure P, volume V, or temperature T. So looking at our first circle, 1.03 atm. Atm is a unit for pressure, so we have variable P. 2.38 atm. Atm is also a unit for pressure, so we have variable P. Now 360 K, K is temperature, so this is going to be unit T, variable T. And the problem is asking us the final temperature. We know temperature is T. Now, every single time we do a gas law problem, I'm always going to give you two numbers of the same variable. The first of that variable, so in this case 1.03, that's going to be 1, so it's going to be P1. And the second one, when it says 2 whatever, that is going to be 2. And then I'm always going to have you 1, and you're always going to solve for 2. So now that we know that, the next thing we got to do is make a table to help us figure out which of the three gas law equations we're going to use. So the table is going to look like this. Pressure, volume, and temperature. So now we're going to fill in all of the numbers, since we already know the variables, into their appropriate position on the table. So we know P1 is 1.03, P2 is 2.38, T1 is 360, and T2 is our question mark. We need to solve for that. So whenever we need to solve for something we don't know, we'll put a question mark since we know that's what we need to solve. So V, we have no information about V, so we're just going to go ahead and cancel that out. Now, looking at all three of the gas laws, there's only one gas law equation that involves pressure, P, and temperature, T. And this is this equation, our P1 over T1 equals P2 over T2. So now that we know what equation we're going to use, let's go ahead and plug in all the numbers we know for each variable. P1 is 1.03, T1 is 360, P2 is 2.38, and we don't know our T2. So now we have to get T2 by itself. Whenever you have a fraction like this, where a fraction equals a fraction with the variable, the first thing we got to do is cross multiply, meaning 360 is going to multiply to 231, and 1.03 is going to multiply to T2. So this is going to be written out as 360 times 2.38, and then equal 1.03 times in our T2. And then lastly, to get T2 by itself, it's being multiplied by a number. To undo a multiplication, we divide that number to both sides. And 1.03 divided by 1.03 is 1, so that's why it cancels. And now you're just going to plug this into your calculator. So you would do 360 times 2.38 divided by 1.03. And your answer for T2, since that's what we're solving for, is going to be 831. And we know the variable for temperature is always going to be K. And that is your final answer for problem number 1. So now let's go ahead and move on to problem number 2. Same idea. All these problems, I'm going to be giving you 3 numbers, and each of those numbers with the unit we want to circle. So we have 291K, 318K, and 2.75 liters. And the problem is asking us to solve for final volume. So let's underline final volume. So now that we have our 3 circles in our underline, let's figure out what variable. Is it going to be P, which is pressure, V, which is volume, or T because it's temperature? Now, our 291K, we know K is a unit for temperature, so this is going to be variable T. 318K, that's a unit for temperature, so T. 2.75 liters, that is the unit for volume, so V. And we're asking us to solve for the final volume, so it's another variable V. Again, we got a number to a number, so the first circle is always going to be 1, and the second one's always going to be 2. We're always going to be solving for 2, so therefore this V is going to be 1. So now that we know where our 1s and 2s and our variables, let's make our table again so we can figure out which equation we're going to use. So now we're going to plug in all of our numbers that we know into the respective boxes. So T1 is 291, T2 is 318, V1 is 2.75, but we don't know our V2, so that's going to be our question mark. Now in this problem, we're not given any information about pressure, so we're just going to X that out. And the only gas law equation that involves volume and temperature is V1 over T1 equals V2 over T2. So now that we know the equation we're going to use, let's go ahead and plug in all the numbers that we know into their respective variables. So V1 is 2.75, T1 is 291, we don't know our V2, so we're going to rewrite that, and then our T2 is 318. Same thing that we did last time. Since we have a fraction equals a fraction, the first thing we got to do is cross multiply. Cross multiply. What this is going to become is 2.75 times 318 equals 291 times our V2. And then finally, to get V2 by itself, since it's being multiplied by 298, we're going to divide 298 to both sides. So we can undo that. And our 291 cancels out. So to plug this into the calculator, you would do 2.75 times 318 divided by 291. And our final answer for V2 is going to be 3.00, and we know the unit for volume is going to be liters. And that is for your final answer for problem number 2. All right, so now let's go ahead and do problem number 3. Again, 3 different numbers, so 3 different circles, and we got to underline what we're solving for. So we have 3.10 ATM, 2.11 ATM, 1.4 liters, and we're solving for final volume. So now that we know our 3 circles and our underline, we can go ahead and assign variables. 3.10 ATM, that is a variable for pressure. 2.11 ATM, that is also a unit for pressure. 1.4 liters is a variable for volume, and we're asking us to solve for the final volume. Now remember, first ever circle, because it's something to something, it's going to be 1 leading into 2. And then you're always going to solve for 2, therefore the V1 is going to be 1. So now that we know our variables and our number 1 and number 2s, we can go ahead and make our tables so it helps us to figure out which equation we're going to use. So now let's go ahead and plug in our circles and our question mark to their appropriate boxes. So our P1 is 3.10, P2 is 2.11, V1's 1.4, but we don't know our V2. So in this one, we're given nothing for temperature, so we're going to cross that out. And the only gas law equation that involves pressure and volume is P1 V1 equals P2 V2. So let's go ahead and plug in everything that we know into this equation. So P1 is 3.12 times 1.4 equals our 2.11. We don't know our V2. Now for this gas law, Boyle's law, it's not a fraction equals a fraction. So we would skip the cross multiplication step, and we'll go right into divide to both sides. Since we want to get V2 by itself, and right now it's being multiplied by 2.11, we would divide 2.11 to both sides. Which means the 2.11s will cancel. So you would go ahead and plug this into your calculator, and you would do 3.10 times 1.4 divided by 2.11, and you would get, for your V2, 2.05, and our unit for volume is liters, and that is your final answer. Now go ahead and do problem number 4 on your own. Pause the video, and when you have your answer, press play. And here's your answer. Now go ahead and do problem 5 on your own, and pause the video, and when you have your answer, press play. And here's your answer. And that's it, guys. Thanks.